Hello everyone. Today we are going to do some examples related to the chapter physical properties of matter, and the examples are related to the modulus of elasticity. So let's start our examples and problems related to this. The first example says that a wire 10 meter long has a cross-sectional area 1.25 into 10 raised to the power minus 4 meters square. It is subjected to a load of 5 kg. If Young's modulus of the material is 4 into 10 raised to the power 10 Newton per meter square, calculate the elongation produced in the wire. Take G is equal to 10 meter per second square. Why the value of G is given? Because you have to convert the mass into weight. First of all, you have to convert the mass into weight, and then this weight will act as the force per unit area, and area is given 1.25 into 10 raised to the power minus 4. So let's do the solution. We know that the Young modulus is equal to force over area multiplied by change in length divided by original length, and we need to find the elongation produced, that is delta L, or change in length. So if we arrange the equation, it will become F over A multiplied by length, original length, over Young modulus. And by putting the values, we will get the answer as force. We know that it is 50 Newton. Why? Because we have multiplied 5 with 10 meter per second square. And area is given in the question, and length of the wire, original length of the wire is given, and Young modulus is given. And when we calculate the value, the final answer will be 10 raised to the power minus 4 meter. So this is how the change of the wire. This is almost equal to 0.1 millimeter. Next question is a structural steel rod has a radius of 10 millimeter and a length of 1.0 meter. A 100 kilonewton force stretches it along its length. Calculate stress, elongation, and strain on the rod. Young modulus of the structural steel is 2.0 into 10 raised to the power 11 Newton per meter square. So radius of the rod is given and length of the rod is given. And while the radius is given, you have to find the area through the following formula. That is, area is equal to pi r square. So we assume the rod is held by a clamp at one end, and the force is applied at the other end parallel to the length of the rod. Then the stress on the rod is given by F over A is equal to F over pi r square. And here we have radius 10 millimeter. So 10 millimeter would be equal to 3.14 into 10 multiplied by 10 raised to the power minus 3. And after calculating the value, we get the stress 3.18 into 10 raised to the power 9 Newton per meter square. The elongation would be, change in length would be from the following Young modulus formula. And by putting the values, we will get the elongation or the change in length 1.59 into 10 raised to the power minus 2 meter. The strain is given by change in length over original length. And by putting the value, we will get the strain as 1.59 multiplied by 10 raised to the power minus 2 meter over 1 meter. And we will have the following value of strain. Next question is a metal cube of side 0.20 meter is subjected to a shearing force of 4000 Newton. The top surface is displaced through 0.50 centimeter with respect to the bottom. Calculate the shear modulus of elasticity of the metal. So here L is equal to 0.2 meter. Force is 4000 Newton. Displacement is 0.5 centimeter. And if we convert this into meter, we will have 0.5 into 10 raised to the power minus 2 meter. And area is, we have to find the area of the cube, because we know the cube area is equal to length side A multiplied by side A. So definitely we are going to multiply 0.2 with 0.2, and the value of area would be 0.04 meter square. Therefore, the shear modulus is equal to F over A multiplied by L over X, length over displacement. Putting the value, we will get the final answer as 4 into 10 raised to the power 6 Newton per meter square. A square lead of slab, okay. A square lead slab of side 50 cm and thickness 10 cm is subject to a shearing force on its narrow surface. That is given, shearing force is 9.0 into 10 raised to the power 4 Newton. The lower edge is riveted to the floor. How much will the upper edge be displaced? So here you can say this is a square lead block and it is a shearing force is applied on it, and as a result it is displaced. You have to find the displacement, how much it has been displaced. Now the lead slab is fixed and the force is applied parallel to the narrow face as shown in the figure. The area of the face parallel to which this force is applied is length over thickness of the lead block. So 50 cm multiplied by 10 cm would be equal to 0.5 into 0.1 meter is equal to 0.05 meter square. Therefore, the stress applied is, stress we know that it is equal to F over force over area. Putting the value, we will get 1.80 into 10 raised to the power 6 Newton per meter square. And we know that shearing strain is equal to the displacement over original length is equal to stress over shear modulus. So arranging the value, we get the displacement as this, and by putting the value, we will get the final displacement as 0.16 millimeter. A metallic cube of side 100 cm is subjected to a uniform force acting normal to the whole surface of the cube. The pressure is 10 raised to the power 6 Pascal. If the volume changes by 1.5 into 10 raised to the power minus 5 meter, calculate the bulk modulus of the material. So you have to find the bulk modulus, and we know that bulk modulus is equal to stress over change in volume. This stress is actually the pressure of the liquid. So P is equal to original volume divided by change in volume, and we have in the question the change in volume is 1.5 and the pressure is 10 raised to the power 6 Pascal. Putting the value in the equation, we will get the bulk modulus as 6.67 into 10 raised to the power 10 Newton per meter square. So this was all our related questions. I hope that you have understood it very well. Stay happy and do study. Thank you.